Hello and welcome to Physical Geology. I want to look over the Topographic Maps Lab exercise 1 here. There were some questions about finding some of these places named on the map. They're a little difficult to find, and I want to point those out and where to look. And so I'll kind of go through this first part with you and show you some of the expectations I have for when you turn in this lab. Well, we'll look at that. We're going to study the map. We're going to look at the contour lines, especially the index contours and the spacing between lines. Remember, the closer the contour lines are, the steeper the slope. Look at some of the symbols, maybe the scale, some landforms, and then we're going to ask you these questions on exercise 1. So the first question they're asking us to look at is this elevation of Wonderland Lake. But before we even do that, let's take a look at some of the important points I want you to see on this map. So I took a picture of the map and I put it on my computer here. Now the first thing to look at is the scale. So this map says it's a scale of 1 to 24,000. So this is called the representative fraction, which means that 1 unit measured on the map is equivalent to 24,000 units measured on the ground. For example, if I measure 1 inch on this map, I'm really measuring 24,000 inches on the map. Since there are 12 inches in a foot, that equates to 2,000 feet. So 1 inch on this map is 2,000 feet. That would be a verbal scale. But for the representative fraction, you always have inches to inches, or I can use centimeters to centimeters. So if I measure a centimeter on the map, I'm really measuring 24,000 centimeters. Then you can see there's a graphic bar scale here. So there's the miles. So note that the zero is kind of not on the ends, or sort of in the middle of the scale. So when you use these, make sure you know where zero is. And then there's a compass rose with true north and magnetic north, and the declination here of 13 degrees for this particular part of North America. And they also have a little inset map here of the state of Colorado. And this inset map shows you where this topo map is in the sense of where in Colorado. So we see Boulder is up kind of the central part of Colorado, more toward the north. Right, so the first question is asking us about that Wonderland Lake. So let's zoom in a little bit on Wonderland Lake. Remember, the index contours are those contours that have the elevation labeled on there. So this one is a 6,000 foot index contour. If we look down over here, there's a 5,800 foot index contour, right? So that's this one here coming through there. And then so that's this one here, and that's 6,000. So if we look at this, this is 200 feet between adjacent index contours, right? So our job is to figure out the elevation of each individual contour. So if we start here at 5,800, think of these as steps going like going up a ladder or a staircase. So I'm going to take 1, 2, 3, 4, 5 steps to cover 200 feet. If I take 200 divided by 5, I get 40. So each contour line is 40 feet higher than the next, or 40 feet lower than the next, depending on which way you're going. If you look at the map, they actually tell you contour interval 40 feet, right? So that's another way. So some maps don't give you this, and you can figure it out just by counting the steps between index contours, but it should give you the contour interval, 40 feet. So for Wonderland Lake, we're going to look closely here. If that's 5,800, this contour line is 56, this index contour, 5,600. And then remember, they're 40 feet, so that's 40 feet lower. So that's 5560, sorry. That's 5560. And then 44 below that is 5520. So 5520, 5560, 5,600, right? So Wonderland Lake is lower than 5,560, but higher than 5,520. So make an educated guess and give me the elevation there. The next question, the elevation of Poorman Hill, and what's our reasoning there? So here's Poorman Hill. And actually, Poorman Hill actually has it's elevated. Its elevation is labeled at 6,485. Is that the elevation of Poorman Hill? Is that the elevation of this? Actually, that's a mine symbol right there, that little kind of upside down Y, or the elevation of the mine. So one way to explain this is, remember, going back to our contours, if this is 6,000, here's a 6,200, which is this guy here, so that's 6,200, and then this must be 6,400, right? 200 feet higher than 6,200. So the index contour here is 6,400. So then I go 40 feet above that, 6,440, another 40 feet, 6,480, and Poorman Hill is a little bit higher than that. So that's where they get the 85. So yeah, it makes sense. So for your explanation on this one, or your reasoning, explain that you use the contour lines to sure enough figure out that Poorman Hill is 6,485 feet. Now we're going to look at the creek just south of Poorman Hill. And we're going to try to figure what's steeper, the banks of the creek or the area around the peak, and what's our reasoning. So here, note that the contour lines down on the banks of Boulder Creek here are very close together. That means it's steep. They're close together. You're going to climb pretty steep slopes here. Up around Poorman Hill, they're a little bit more widely spaced, so it's a little bit not flat up here, but it's a gentler slope here, right? So this is more gentle. This is steeper, right? And then again, your reasoning is how close together the contour lines are. Now for question 4, they're asking us if we're going to walk from Poorman Hill down to Boulder Creek directly south, what would be the relief? So this word relief means the difference in elevation. So if something is 80 feet high and something else is 40 feet high, then the difference is 40 feet because that's the relief, the difference in elevation between the 2 points. So we're going to sketch a path and then we're going to figure out the relief here. So let's put a little line here. In fact, I think I have the tool working already. We'll go straight south here to Boulder Creek. And note that Boulder Creek down here is going to be somewhere lower in elevation, lower than 6,000 feet. So remember, each of these is 40 feet, so that's 5,960, 5,920, 5,880. So it's a little bit less than 5,880. So let's make it 5,860 or 5,870 just for simplicity, 5,870. So we'll say that 5,870 feet is going to be that elevation down there. And we know this is 6,480. So your job is to figure out the relief. So take this number, subtract that number, and that'll give you the relief. And I think it's around 615 is what you get, right? And I think I've already kind of labeled that there. So the next question is going to ask us to use that 615 we get here, the relief. And that's a vertical distance we go from the 6485 to 5570 right here, 615. So that would be our A in this problem here. But we're not really walking a straight line there. We're walking more of a slope. So we really want to figure out the true distance we're walking, because that horizontal distance really, if we use the map scale down here, we get about 2,000 feet. So that line would match about this distance here. So that would be our horizontal distance that we're traveling. So my little triangle, that's 2,000 feet there. So that would be my B. So using Pythagorean theorems, we got A squared plus B squared equals C squared. So we square that, add them together. That should equal C squared. So when you do that, 615, you square that, you get 378, 225. So write that down. So that's this squared. Then we take 2,000, square that, that's 4 million. We add it to the 378, 225 that we got for the 615 square, and that's 4,378,000, right? So that's C squared, but we don't want C squared, we just want C. So to get rid of the square, I take the square root of both sides. The square root of C squared is going to be C. I take the square root of this, so that gives me 2092. So let's add that on there. So in this case, we're seeing this distance is 2092. So that's a true distance we're walking as we walk down the slope from this elevation, 6485 to 5870. Right? So you want to show those calculations, take a picture of that as well. Now the last problem is asking you to find this intersection of Canyon Lane and Broadway. And you're going to walk from Poorman Hill, and based on the contour lines, you want the easiest path. Then you're going to take a picture of that to get down there. And when you look at this, where is this Canyon Lane and Broadway? So if we look at our map, you see Broadway is here and there's Canyon. And I've already kind of outlined where it is. So we'll zoom in a little bit here. Yeah, so there's Broadway and Canyon right there. So our goal is to reach that spot there. And we're going to try to get to that spot over here from Poorman Hill. So your job is to figure out the easiest path. So right away you say, well, I'm just going to go down to the creek here, to the road, and walk my way down there. But one problem here, this is really steep. You don't want to go down that. You want to go where the contour lines are more widely spaced. So you can probably chart a path that's a little bit easier to walk up in this region here. So yeah, look how flat this is in here. Pretty gentle slopes in there. And then maybe make your way down to this Sunshine Road and then take the way down there. Or maybe you can figure out a way to kind of get over to some of these roads and make your way over. But whichever way you think is the best. Again, this exercise is just kind of having you judge the spacing here and what would be an easier way to get down to this intersection from Poorman Hill. So once you do that, you can freehand the drawing, right? You can sort of start making your way in here. Yeah, I would probably do this. So it's pretty gentle in here. Actually, this is really gentle right there. Right there. And then I would start just going down this road. That's good. Staying in the low spots here. And finally, when I get down to the city, I can start just taking these intersections here and making my way over here. And then almost there, and voila, I've made it, right? Oh, it kind of corrected that, but I don't want that. So anyways, you saw how I sort of did that, and you want to take a picture of that and then submit it for your exercise. All right, well, I hope that helps. See you next time.